Welcome to the Duplex pump system project. This is my first project of 2 due by the end of the year. This system has 2 pumps, 2 tanks, and an HMI panel view on the front that runs the whole process. The first component that we will take a look at is the banner light stack. The first mode we see here is when the light stack is in a yellow condition. When it is in yellow, that means the system is disabled. The next mode shown is when it is completely clear of all faults and ready to be run. When the green light is lit, that means either pump 1 or pump 2 is running. Our final mode is the emergency stop enable bit. As we can see here, the white light will flash to let the user know that the emergency stop is active. Now we will enter our Duplex pump system. We will first log in. We will log in as the supervisor. And the password we will set as capital S, lowercase UP. Click login, and the supervisor will show up. We'll go to our main screen. Here on the main screen, we have a general display of the whole system. We have our 2 tanks, our 2 pumps, and the water level inside each of them. On the left side, we have pump 1, pump 2, trends, alarms, and our logout button. And on the right side, we have the PID set point, what mode we are in, how to change the mode, the HMI start bit, and the system enable bit. Let's look a little bit closer at our navigation screens. First, we'll go to pump 1. As we can see here, we have the clear faults button, which clears all the faults for the pump 1. The pump 1 enable, which can be used in hands mode to turn on pump 1. The pump 1 disable, which is used in hands mode to disable the pump. And the maintenance pump. We also have our cycles, our runtime in minutes, our frequency set point, and our output frequency numeric display. We also have the navigation screens to continue navigating through the system. Now we will take a look at pump 2. As you can see, it has all the same values as pump 1. It has the clear faults for the VFD, the pump 2 enable, which is used in hand mode, the pump 2 disable, which is used in hand mode, and you can also put it under maintenance. It has its runtime minutes and its cycles, as well as its frequency set point. Next, let's go over and look at our trending tab. The trending tab ranges from 0 to 100. It displays our pump 1 hertz, our pump 2 hertz, our PID set point, and our tank level. As the system runs, you will see these values change, and they are logged, and you can come back to them and see what the frequency ranges or the tank level set points were. Now let's go take a look at our alarm page. Our alarm page has a basic setup with a clear button and the alarm banners displaying the alarms that pop up throughout the day. You can press the clear button to remove those alarms as shown. Now that you know the basic layout of all the navigation screens, let's look a little bit deeper into the process. Now when we look at our main screen, we can see we are in hand mode. And in hand mode, we're going to change the PID set point down to 75 here. And as you can see, no pumps turn on, not pump 1 or 2 turn on. So we manually start those in hand mode. So I'm going to fire pump 1 here. And as you can see, while that's running, it's going to run up to our set point of 50. And also in hand mode, we can change that set point, which you can't in auto mode. So here we'll take a look at the frequency set point. It's at 50. We'll fire that to 60. And as you can see here, the pump frequency will start up to that 60. Now we'll navigate over and disable pump 1. And we'll see that frequency start to wind down. Go back to our main screen. You can see it was lit up there in the green, pump 1. Let's check out pump 2. Go over to pump 2. We'll fire that one because we're still not to our set point. That's at 50. Let's turn this down to 40. And that 30 to 40 range barely pumps any water. It just keeps enough to keep spewing into the tank above it. And as that's pumping, you can see our frequency will change. So the pump is slowing down because we reached our PID set point. Now that that pump is shut off, let's go back to our pump 2 and let's reference the maintenance button. The maintenance button, once you click it, it'll turn it into under maintenance mode. When the pump is under maintenance, it can absolutely not be run. So no matter what you do, we'll change our set point down here. No matter what you do, you cannot turn this pump on. So see, fire enable will not turn on. But since we are below our set point, 1 will turn on because it is currently not under maintenance. Now if we navigate back to the main screen, we can see pump 1 is on and running. But if we go to pump 2, that is still off. Let's turn the maintenance off. And as you can see, we can turn on pump 2 now. And now both pumps are running. Now both of our pumps are running, and they will continue to run until the PID set point is reached. This is how you utilize the hand mode. Now we will take a look on how hand mode works in the lab. The user walks over to the valve and opens the valve. As you can see, the water starts draining into the tank below it. The tank will not start running because we are not in auto mode. The user walks over to the screen and selects which pump he wants to run. Pump 1 is enabled, so as you watch, you will see water start to flow into the top tank. The water will continue to pump until our PID set point has been reached. Now that we know about hand mode, let's take a look at auto mode. We'll go to our PID set point and we'll turn this down to 65 so the tank level is greater than our PID set point. As this happens, we will see an alarm pop up that is calling a pump to run. Pump 2 is enabled and it will continue to pump the water until it is down past the 65% set point. Now if we go take a look at our pump 2, we can see that it is running at a full 60 Hz even though our frequency set point is set at 40. This is because when we are in auto mode, we do not want the pump to be set at a certain frequency. We want the pump to be able to run until it reaches its PID set point. Now if we turn this PID set point down to 55, we will see we will get the same alarm to call, but pump 1 will fire instead of pump 2. This is the toggle logic used so we do not burn up one pump faster than the other. If we look at the frequency, it's going to catch 60 Hz, even though our frequency set point hand mode is at 60. If we turn this down to 50, as you can see, the pump will not slow down because we are in auto mode. If we go and try to disable or enable our pumps, this will not work because we are in auto mode and they will run until it reaches its set point. Once pump 1 reaches its set point, it will shut off. This has been a basic layout of how auto mode works in this system. Now let's take a look into the lab to see how this works. The user opens the valve and then closes it. A pump has now been called to run because we are over our PID set point. The pump will now run until we are back under our PID set point. Now let's take a look at our final mode, which is the high demand mode. Once the valve is open completely, an alarm banner will appear because we are over our PID set point. As the water continues to flow in and reaches a set point over 90, both pumps will kick on and continue to work until it is back beneath the PID set point. Now let's take a look on how this works in the lab. The user opens the valve and the water starts rushing in from the top tank into the bottom. Since we are in auto mode, one of the pumps has already started running. The second pump will begin to run once the set point of 90 has been reached. These pumps will both stay on until it's back under the PID set point. Here's a quick time lapse of the difference between auto mode and hand mode. In auto mode, the tank fills back up, but in hand mode, the user must control which pump he wants to run in order to fill the tank. Now let's look a little deeper into our cabinet. On the right-hand side, we have two PowerFlex 525s. Those control both of our pumps. In the middle, we have a 5-port Ethernet switch that controls all the communications for the whole system. And on the far left, we have a Point.io remote rack that communicates with the PLC, our light stack, and our pressure sensor. Now looking at the bottom half of our cabinet, we can see our power supply, our disconnect switch, our safety circuit, and the incoming power going to the VFDs. The power supply supplies 24 volts DC to all the devices in the system, except for our AC going to the pumps. Let's take a look at the AutoCAD drawings for each component. We have our conceptual drawing, our RS20 Hirschman 5-port switch. As we move along, we go to our compacts logic, which is located inside the classroom. We connect this by using the remote rack inside the control cabinet. Next, let's move on to our banner light stack that is mounted on top of the controls cabinet. Take a closer look into this. We can see all our lights and what they are tied to. As we keep moving, we go to our incoming power, which is coming from the 3-phase into the disconnect. That is running into our VFDs, which are controlling our pumps. Then we will look at our Point.io card and our remote rack. This is controlling the pressure sensor and all of its functions. Next, we will look at our power supply. This is a rundown of all the devices that are connected to the power supply. Then we'll take a look at our VFDs, pump 1. This shows the connection of the incoming power connected to the motor. As we look at VFD 2, we can see the same exact setup, with having the inputs just go to different terminal blocks. Now we will take a look at the safety circuit. The safety circuit is a major backbone for this project, as the system cannot run unless all faults are cleared. Next, we will take a look at the overview of our PLC routine. This PLC routine is broken up into different subroutines, with this first page being the main routine. This page displays important parts of our system, such as the call for pump, the toggle bit, the set points, and the faults. Our next page is just our light stack. This controls the outputs for each color and also our buzzer. It displays basic logic to tell when each light should come on. The next page we will navigate to is our PID loop. This is just a basic setup that I found online on how to use a PID. Next, we'll go to our Pump 1 subroutine. This page controls all the inputs and outputs for Pump 1. It also has various HMI bits that are interactive with the HMI, such as setting frequency and the PID set point. It also has various counters and timers to keep track of things like cycles and runtime use. As we navigate to the Pump 2 subroutine, we can see it is basically a copy of Pump 1 subroutine. Since we are using the same exact VFD as we are in Pump 1, it is the same exact type of logic. Now we'll walk through the printed out user manual. As you can see on the screen, it starts off with the light stack and giving the conditions for each of those. As you work your way down, it shows you the security tab. It shows how to utilize the main screen and all the components that go with the main screen. It also shows how to use the PID set point properly. Then proceeds to show how to utilize pump 1. Gives all the information on pump 1, how to set different set points, the frequency. It shows the same setup for pump 2 and how to use the enable and disable and so on. Next, it shows the trending page and what all the values mean and how to use that properly. Then it explains the alarming page. Here is a quick summary on how the Duplex pump system actually runs. We will now look at some of the project documentation. We have the project description, the project plan, the environmental concerns, the system power, the speed requirements, and the network protocol. We also have the conceptual drawing here that you saw in CAD. Moving forward, we have our parts list. This provides detail on each individual part inside of the system, such as their amp rating, their wattage rating, their voltage rating, and also a link to the part. Next is our BOM, or bill of materials. This shows a picture of each product, how many we used of each product, the cost of each product, and also a link provided on where to find the product. Now we will look at what went well and what also needs improvement list. One on each of the lists that was very big to me was I thought in class I stayed very focused and worked on my project diligently, but one thing I know that needs improvement for this next project is that I need to work harder outside of school. Here is my final summary on the Duplex pump project. Overall, I thought the project as a whole went very well for me. Programming has always been a little more difficult for me than other areas, but I feel this project expanded my knowledge and made programming a little less stressful for me.